Today we are starting our unit on quadrilaterals, and a quadrilateral is simply a polygon with 4 sides and 4 angles. So it could be something that's not really special, like that, or it could be a more special one like a rectangle. It could have something that's going in, like that, or it could be something kind of like a kite or a diamond. Anything with 4 straight sides is going to be considered a quadrilateral. Any type of polygon can be considered concave or convex. So concave polygons have at least one angle that is more than 180 degrees. And they go in like a cave. So that would be an example of a concave quadrilateral. You could have a shape like this that is not a quadrilateral, but it would still be concave. For your convex polygons, all of the angles are less than 180 degrees. And that's the ones we typically think of. So that would be these other 3 up here. Could be a pentagon, whether it's regular or not, a hexagon, an octagon, anything, not like that, anything like that, or with even more sides, as long as none of them jut back in. If you did have an angle that's 180 degrees, so let's do that. I have this one, and then I turn that one in, and then I'm going to make that angle 180 degrees. It becomes just a line. Even if I connected that right there is 180 degrees. So you can't have one that's exactly 180. It's either more than or less than. Within our quadrilaterals, we have 6 special ones that we're going to focus on. Parallelograms, rectangles and squares should be somewhat familiar. Rhombi, which is plural for rhombus, trapezoids, and kites. You should have seen most of those. We're going to focus on a little more detail from them, but they should be familiar. You will need to know all of the properties that we talk about. Properties of all quadrilaterals. They have 4 sides. They have 4 angles. And as we looked at earlier this week, the sum of those 4 angles is going to be 360 degrees. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. You can mark that they're parallel with the arrows. So these 2 sides having the double arrows means those 2 are parallel. Even with the single arrow, it just identifies that those 2 sides are parallel. So we can fill in our table. Opposite sides are congruent. So AD is going to be congruent to BC. And I could do the same for my top and bottom sides. So AB is congruent to DC. We also know that opposite angles are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D. Consecutive angles are supplementary, so we know that from parallel lines cut by a transversal. The same side interior angles, as we often call them, or consecutive angles, are supplementary. So the measure of angle A plus the measure of angle B equals 180 degrees. Could do that for my bottom 2 angles too. Measure of angle D plus the measure of angle C equals 180 degrees. I could also do that if I was just looking at the left 2 angles and the right 2 angles. So the measure of angle A plus the measure of angle D equals 180 degrees. And the measure of angle B plus the measure of angle C equals 180 degrees. Essentially, when you're looking at your parallelogram, any 2 angles that are next to each other, whichever way, are going to add up to be 180 degrees. They're supplementary. And then we also know that our diagonals bisect each other. So if we draw our diagonals, apologize, I'm on a very shaky surface. And let's just go ahead and say they cross here at X. That first one I drew, that AC, gets cut in half by the second one. So that means that AX must be congruent to CX because it was cut in half right there. That would also be true for the other diagonal, so dx is going to be congruent to bx. Okay, now let's actually use these sums. So find the values of x and y. Okay, when I look at x, it's on a side. I know the opposite side, which is 13, and I know that opposite sides are congruent, so I can say that x plus 6 equals 13. Subtracting 6 from both sides would give me that x equals 7. For my y, it's an angle, and I know the angle that's opposite of it, so I know that those are congruent, which means y is 68 degrees. Sometimes it is just that straightforward. Sometimes we make you work just a little bit, so pause this for a second, see if you can work through these. Okay, starting with x, it's a side. I know the side opposite it is 37, so I can say 2x minus 3 equals 37. When I add 3, I get 40. Dividing by 2 gives me x is 20. If you haven't yet, go ahead and pause it and see if you can find the angles for y and z. Y is opposite of the 123, so I know that it is going to just be congruent to that, so it is also going to be 123 degrees. Z is consecutive or next to that 123, or you could also think of it as being next to the y, which was also 123, which means that z plus the 123 is going to equal 180. They are supplementary. So if I just subtracted my 123 over, I get that z equals 57 degrees. In this example, we have quadrilateral LMNP. It's a parallelogram, and I want you to find some specific angles. Again, pause it and see if you can do it on your own. Right, angle PLM is the first one, so that would be this angle up here. It is opposite of this angle down here, which means it is congruent, and I know that pieces of them are 42 and 66. So if I add the 42 plus the 66, I get 108. So I know that the measure of angle PLM is 108 because it needs to be congruent to the measure of angle PNM, this one down here, since they are opposite. For measure of angle LMN, you can think of it as being consecutive or next to or supplementary to either the angle we just found or the angle down here at the bottom. Either way, that angle plus the 108 is going to give me 180. So if I do 180 minus 108, I get 72. So the measure of angle LMN is 72 degrees. Finally, to find D, that's on one of the sides, and I do know the side opposite it, which is 2D, which means D must be 11. For example 4, we are still looking at a parallelogram, but this time instead of looking at angles or sides, we're looking at our diagonals. And I know that the diagonals bisect each other, so that means JG cuts FH in half, so those two have to be the same. I also know that that would be true for the other diagonal, so JM and GM are going to be congruent as well. First thing I ask for is MH. MH is the other side of that diagonal, so it must be congruent, therefore it's 5. For FH, that'd be this 5 plus this 5, which is 10, so FH is 10. On the next part, I do want you to pause and on your own complete the rest of this page. Then I'll put the answers up for you to check and briefly talk about each of them. Hi, here are our answers, starting with number 1, your concept checked. My sides, I should have opposite sides being parallel and congruent. I had to abbreviate a little bit here to fit it in. For your angles, the opposite angles are congruent, but the consecutive angles are going to be supplementary. For my properties of my diagonals, they bisect each other or cut each other in half. Which, interestingly enough, we could also add that if they're cutting each other in half, like you see over here, the midpoint of each one is going to be the same. So they do have the same midpoint as well. 3, I asked you to draw a parallelogram with one side twice as long as the other. You could have drawn that several different ways. Just try to make sure one side is twice as long as the other. So I had 4 for that longer sides and 2 for the other sides. On 4, 5, and 6, I was looking at this quadrilateral. I know that SV is going to be congruent to VQ because they are one of the diagonals that the other one cut in half. I know that triangle VRS, so that's this triangle up here, is going to be congruent to this triangle down here. Now labeling it, I do need to make sure I keep the corresponding parts in the same order, so VTQ. I have diagonals bisecting, I have opposite sides being congruent. That'd be enough to give me side, side, side. Or I could use side, angle, side and say that the interior angles there are vertical angles. Several ways to do it, but I do know that those are going to be congruent triangles. Angle TSR, so kind of written all over this, but that's this top angle up here, is going to be supplementary to QTS, the bottom right, as well as SRQ, the top left. And that's because consecutive angles are supplementary. On 7 through 12, we're looking at this figure over here. To find the measure of angle MJK, it is opposite of angle MLK, so they're going to be congruent. That one's 30 and 70, which is really 100, so this one up here, as I listed, was 100. Which I know means that this top right angle, JKL, and bottom left, JML, are not only congruent, but they are going to be supplementary to that 100. So those were each 80. Angle KJL, so that's this little angle up here, is going to be congruent to this 30 down here because they're alternate interior angles with parallel lines, so they are congruent. For A on number 11, it's a side, so I just set my opposite sides equal. I got A equals 7. Same thing on number 12, I set my opposite sides equal, and I got B equals 21. In class, in the next 30 minutes or so, however much time you have left, you should be working on the back of that, the one that says practice 6-2 on the top. You need to complete that, either in class or for homework. We will pick up tomorrow with our rectangles, rhombi, and squares.